Now let's look at the graph of the trig function for cosecant. Here I have a picture of the graph, and you can see that I have vertical asymptotes occurring. I have the green line here, which would be the actual graph, where it looks like a bunch of parabolas. One thing I want you to think about, since we already know that cosecant is the reciprocal of sine, their graphs are actually related in a similar fashion. So let me just kind of quickly draw on here for you the graph of our sine function, which looks similar to this. And notice that everywhere I'm crossing the x-axis, I have a vertical asymptote, and everywhere I have a maximum or a min, then that's where my secant function is going to touch. So we're going to use those ideas to be able to graph the cosecant function based on what we already know sine to graph like. Some properties of cosecant are defined as there's vertical, the domain would be between these two vertical asymptotes. The range would be from negative infinity to negative 1 and positive infinity to positive 1. Since cosecant and sine are both related, they both have the same period. So the period for both of these functions is 2 pi. And since the range of my function moves off to negative and positive infinity, then I would have no amplitude. So let's see how we're going to graph this function. This is just telling me that I need to remember that in order to graph cosecant, I'm going to be relating it to sine, or I'm going to be using sine as a guide. So our first example we have here says I want to graph this function and over 2 periods. We're going to start by identifying what A is, and although I don't have an amplitude for cosecant, I still need to know what A is when I graph this on the y-axis. So A in this case, since this value here is being multiplied to the function, that's A, 1/2. Now, B in this case, in this particular function, is 1, and therefore the period, which is 2 pi over B, would just be 2 pi. So I know I'm going to have an interval between 0 and 2 pi, and ultimately I want to graph this over 2 periods. So we're going to go ahead and we're going to break this up into my values that I need. So I'm going to go between 0 and 2 pi, just like I did in the past when I wanted to graph the sine function. So halfway between 0 and 2 pi is pi. Halfway between that is pi over 2, and halfway on the other side is 3 pi over 2. So the third thing I want to address is the phase shift. This function has a phase shift since I am adding something into the function, or I'm adding it to the variable x. And this is going to be the opposite sign, so we are going to be technically subtracting pi over 4 from each of these intervals that I've just created, or each of these points that I've created. So we're going to subtract pi over 4 from each of these 5 values, and you can do that using your calculator or you can do it in your head. Either one doesn't matter to me. So I'm just going to pause the video, fill these in, and we'll come back to. So when I subtracted pi over 4 from each of my original values, these are the new values I came up with, and those are the numbers that I'm going to use to fill in on my x-axis. Now, I don't have a vertical shift occurring here, so I'm good, and I can move on to actually putting some numbers on the graph. So we're going to come over here. We're going to lay out our x-axis. I know that one phase is occurring, or one period I should say, is occurring between negative pi over 4 and 7 pi over 4. So let's just put that on here. And 7 pi over 4. And I could either move in the positive direction over here by 2 pi, or to make 2 periods here, or I could move in the negative direction by 2 pi to make 2 periods. And I happen to just do it in the negative direction, so we're going to just go ahead and put on here negative 9 pi over 4. And that came from taking negative pi over 4 and subtracting 2 pi to get negative 9 pi over 4. And if you just can't see that, just do it in your calculator and you'll see where those fractions actually come out. So let's come back to the original one. I'm going to go halfway in between, which is 3 pi over 4, and I'm going to write these numbers down, which I've already calculated. And then I'm going to come and do it in this second period over here to the left. So halfway between ends up being negative 5 pi over 4, negative 7 pi over 4, and negative 3 pi over 4. Okay, so I have my two periods drawn on here. The next thing I want to do is I want to draw what we're calling the amplitude, or what we're letting A be on my graph. So that was positive 1/2 and negative 1/2. Again, I don't have an amplitude, but I do need those points. Now, I'm going to draw just by using dots. I'm going to lay out the dots I would use on the sine function. So my sine function is going to start on the x-axis at negative pi over 4. It's going to peak, or it's going to have a maximum at pi over 4, cross at 3 pi over 4, have a minimum at 5 pi over 4, and cross at 7 pi over 4. So before I go any further, I want to define what that means for us. Everywhere I cross the x-axis, I have an asymptote. So I'm going to come in and I'm going to just draw my asymptotes before all of these dots start to go together, run together. And everywhere I have a maximum, I have a parabola, and everywhere I have a minimum, I have a parabola, and that's how we draw it. So let's do that on this next period over here. So I'm going to lay out what my sine function looked like. So if I am crossing here, then I would go down for sine. I would cross for sine. I would max out over here, and then I would come back and cross again. So everywhere my function would have crossed the x-axis, I put an asymptote. And everywhere I have a peak like this, or a maximum or a minimum, I draw the parabola. So you can see how I'm using the sine function to be able to draw the cosecant function.